Hello, welcome everyone to my Physics 2211 Lab 2 projectile motion. So in this lab, I will be covering the introduction, physics model, experiment, code, discussion questions, and the conclusion of a projectile motion. So the purpose of the video today is to observe the motion of an object that is in projectile motion. We want to analyze the interactions acting on the object, including the interactions of gravity and the interactions of gravity and drag force. Next, we want to compare the position of an object using the models that we created. And some of the lab information is that the object is a standard expo eraser, and some of the tools that we used were Tracker, an iPhone, and Excel. The main physics principle ideas that were present in the experiment includes Newton's second law, also known as the momentum principle, to calculate the net force acting on an object, the gravitational force, along with the drag force, are the two interactions that we included in the net force. So it is very important to take these two forces into account. The velocity update and position update equations were necessary to determine the final position and velocity of the object over a period of time. And the models that support these ideas are the position and time graph and the velocity time graph. So for the experiment itself, the mass of the object was 0.05 kilograms. The calibration that we used were a meter stick in the vertical and horizontal directions, and the direction of the object was in the negative x, positive y direction. And some of the initial conditions were that the initial position was 0.025, 0.271 meters. The initial velocity was negative 0.21, 3.6 meters per second. And the initial time was 0 seconds, and the final time was 0.644 seconds. The systems and surroundings, the system is the expo eraser, and the surrounding is the ground, atmosphere, and the person in the video. In the gravity-only code, the initial conditions that were accounted for were the ball's mass, its initial position, initial velocity as we calculated in the previous slide, and in this case, the drag force constant was set to 0 because we're only taking the force of gravity into account. And in the while loop, the net force equation was set equal to the weight force, which is mass times 9.8 meters per second squared. Meanwhile, the position update and velocity of the equations were changed to ensure that the values were changing at every iterative step. And in the case for the drag and gravity, the initial conditions all remained the same. However, the only thing that we changed was the drag force constant B, which we set to 0.021. And so this value was found by repeatedly running the code, and in the while loop, the velocity update and position update stay the same, while the only thing that changes was the net force that now takes drag into account, making the equation equal to the weight force plus the drag force. And so when comparing the models to the data in the code, we can see that all curves have the same initial conditions and similar trends, but the curves eventually separate after some time. This time, however, the drag curve is represented in the cyan color, as you could see in the graphs. And so what does it all mean? So terminal velocity is defined as the highest velocity attained by a falling object. Terminal velocity is reached when the acceleration of the object reaches 0, also known as a constant velocity, meaning that the upward interaction is counteracting the gravity, and so that force sums up to 0. And according to Newton's second law, force equals mass times acceleration, and that force is seen to be 0, which is why the acceleration is 0. And so what if an object is initially thrown upwards? Well, it would take longer if I threw it up, like straight up, and we could change that in the code by setting the x velocity of the vector to 0, while changing the y velocity to the magnitude of the complete velocity. So, and once we run the code, we see that the new time that it takes to reach the original height is 0.693 seconds, but the previous time to reach the original height was 0.55 seconds. So we see here that it will actually take longer for it to reach that original height. And so in conclusion, some potential sources of error was tracking could be off in the tracking system, as it's a pretty old software. the value of B in the drag force equations could be inaccurate, and the expo eraser is not a perfect sphere, so there could be some wobble forces that we did not take into account.